Hey folks, we're going to talk about a concept in Investigation 21 called the electron volt. But other words we need to know are voltage, power, joules, work, a quantity of 1.6 times 10 to the 19 joules, a quantity of 6.2 times 10 to the 18 charges, and a quantity and the word charge, which we show. This is very important with the symbol E. So whenever you see the symbol E, think of charge as also the charge of one electron. Now, when you're looking at the slide, I want you to think about how we calculate voltage. It's the power over the current. I'm going to use an example using 0.20 joules per second and dividing that by 0.20 amperes. So as you can see, we get as an answer 1.0 joules per second per ampere, or 1 volt. And as a reminder, 1 joule per second is the energy transferred per second, and 1 ampere is the rate of flow of electrons. So I've circled in pink a few words here that we want to focus on. We can think of this volt as the energy transferred to electrons. But how many electrons? Or how many charges? Well, the number is 6.2 times 10 to the 18 charges, which we can also show as 6.2 times 10 to the 18 E. That's a lot of charges. In fact, we rarely actually ever write this number. There's another quantity, there's another way to say 6.2 times 10 to the 18 charges, but we're not going to use it in this lecture. So, 1 volt is the amount of work done by the battery on 6.2 times 10 to the 18 charges. But how about one little lonely itty bitty charge? What is the amount of work done on that little charge? Well, we can set up a ratio. If 1 joule is the amount of energy transferred to 6.2 times 10 to the 18 charges, we can set up a ratio on the other side using x as the amount of energy for 1 charge. When we do the calculation, we get 1.6 times 10 to the negative 19 joules. So that means that 1.6 times 10 to the negative 19 joules is the amount of energy that was transferred per charge by a battery. That is 1 volt. Well, we don't want to use this number all the time because it's a really large number. So we came up with another quantity called the electron volt, meaning that 1.6 times 10 to the negative 19 joules, which is the amount of energy a 1 volt battery passes to one little itty bitty charge, is also 1 electron volt. So the quantity here, and now this is a ratio we can always use. 1 electron volt is always 1.6 times 10 to the negative 19 joules. So therefore, we can say that a 1 volt battery will perform 1.0 joules of work on 6.2 times 10 to the 18 charges, or it will do 1.6 times 10 to the negative 19 joules of work, or 1 electron volt of work on 1 charge. Again, this is for a 1 volt battery. So the question is, well, how about a 5 volt battery? or a 6-volt battery, or a 3-volt battery? It's actually pretty simple. A 5-volt battery, therefore, will do 5.0 electron volts of work on a single charge passing by. Similarly, the work performed on a single charge in a 6-volt with a 6-volt battery is 6.0 electron volts, and in a 3-volt battery we are left with 3.0 electron volts. Now let me just emphasize here that this is all per one charge, 1E, one charge, one charge. I hope this helps, and good luck with Investigation 21.